Hello, we're about to start a new section of physics called thermal phenomena. And today we're going to talk to you about three very important concepts that will be with you in our next few lessons. They are temperature, energy, and heat. In life we often meet with these concepts, but we do not always have a correct idea of what they are. So our task today to understand these concepts, to look at their physical side and where we can apply these quantities and in what phenomena they will show themselves. So what is temperature? Here we say that it is the degree to which the body is heated. So different bodies in nature are heated to different temperatures depending on their surroundings. And the temperature will be related to the state in which this body is at the current moment of time. You and I know very well that any body consists of molecules or atoms, which move continuously and interact with each other constantly. Therefore, the temperature will show in which thermal state the body is at the current moment of time. So we can say that temperature is a measure of energy of particle motion, because in fact the more intense is this motion, the higher the temperature of this object. So first of all, for temperature as a quantity, we can say that there's a very close relationship between this parameter and the average kinetic energy of the motion of the particles inside the body. If, say, a body has a certain number of molecules, then multiplying this number of molecules by the energy of one molecule, we get the total energy of the body. It is also called the internal energy of this object. And in this case, we can compare the presence of this energy and temperature to a well-known fact in mechanics. Let's see what it looks like. For example, we have two communicating vessels that are different in cross-section. Here, let's say the cross-section is A1, here A2. When we pour some homogeneous liquid into these vessels, then by the law of these vessels, it's set at the same horizontal level. That is the state of equilibrium of this system. Now we can compare this system to two bodies that have different sizes and therefore have different numbers of particles in them. But when these bodies are in contact, the temperature of these objects is similar to the level of water in these vessels. So if the temperature of these objects is the same, there will be no movement of heat from one body to the other. That is, the energy will remain at its fixed value. So here this model shows that an imbalance between the two temperatures of these objects will cause a transfer of energy from one body to the other. In this case, we can say that the body that has the higher temperature, let's denote it by the letter T1, which has been brought into contact with a body that has a temperature of T2, and T1 is greater than T2, moves at different speeds. That is, we can show here that this motion is absolutely chaotic, and such motion of molecules is called thermal motion. So when these two bodies come in contact, there is a transfer of energy from one body to the other. And let's say the average velocity of the molecules of the first body and the average velocity of the molecules of the second body will also be in the same ratio as the temperature. And so from one body to the other, we'll start to transfer a certain amount of energy in that direction. Again, until when will this transfer of energy take place? Until, as we have seen on this model, the temperatures between these bodies become equal. That is, thermal equilibrium will occur in this system. So the two parameters that we're talking about today, temperature and energy, they're going to be closely related to each other, and often the temperature is often referred to as a measure of the average kinetic energy of particle motion, because in general the two are sometimes even identified with each other. So what is heat? Heat in this case is the flow of energy that passes from one body to another during heat transfer. So when we have an imbalance between these two systems, as in the case of two vessels that have different levels of liquid in them, then in this case, you and I know very well, from the vessel where the liquid is at the higher level, it starts to move. Movement towards the vessel where the liquid is at a lower level. And in this case, the flow of liquid that will flow from one vessel to another will equalize these vessels in terms of liquid level. The same thing will happen here. So the result of this heat exchange is we have a situation where bodies will have the same temperature and therefore the same average velocity of the molecules. And here we can simply designate it as the total temperature of a given object. So these three concepts that we've talked about today will describe all the thermal processes that we're going to talk about next. And it's very important to realize that temperature, as well as a number of other parameters. Temperature, as well as a number of other parameters, are the main quantities that describe the state of the system as a whole. In the next lesson, we're going to talk about how temperature can be measured and what scales we can find in our lives today. That's all for now. See you all soon. Goodbye.